Hey guys, um, this is Chapter 8 and Chapter 6 lecture. I cover two chapters in this lecture because there's brief information in both chapter, but still the information is important enough to cover, so I just combine the two chapters. And I start with Chapter 8 first because we just finished with nutrition, so, hopefully you understand how, at least some basic concepts of how to develop a healthy eating habit. Now it would require, more study of nutrition. But at least you'll have some basic, some basic rules or guidelines to follow in order to put together a healthy diet. But this chapter will talk about what happens if you don't follow a healthy diet, or what could happen. And that's why it's called the chapter. The name of the chapter is Managing Your Weight. Okay, so a brief discussion on obesity. I'm sure everyone is familiar with the term obesity, and I'll talk about how it's defined in a second. But obesity has become a national epidemic over the last 3 or 4 decades, really. But recently it's really exploded, and there's been lots of different reasons why this has happened. But in terms of basic definitions. It's a result of energy imbalance. You're talking about consuming more calories than you're actually burning off. Okay, so there's the different reasons why this happens. You can see here an overconsumption that pretty much means eating too much, too little exercise, or sedentary lifestyle where you're not exercising or burning off any calories. So pretty much all the calories you're consuming are being stored in the body, which, leads to, an increase in body fat and eventually obesity. Some people are genetically predisposed to obesity or high body fat. Doesn't mean that it's automatic. It just means you have to work harder to prevent the onset of obesity. Let's see, some demographical populations are more affected or more at risk or susceptible than others. But again, it's all about lifestyle. I mean, the risk factors are risk factors. They're not causes. You still have every opportunity to control your health and especially your body composition. So this chart shows the overweight and obese populations over the last 40 or 50 years, and you can see the data that's presented on this graph began in 1960, so actually almost 60 years ago now. Okay, you can see in the 1960s, early 1960s, the population, or the percentage of the population that was overweight was just under 40%. And if you look across the board all the way to the most recent numbers, which is the 2009-2010 year, which is, roughly about 8 years ago or so, you can see that there wasn't really that much of a difference or really that much of a change in the overweight population. So pretty much over the last 50 years or so, people have been overweight, just under 40% in 1960, just under 40% in 2010. But when you look at the blue line, this represents the obese population, or the percentage of the U.S. Population that's obese. You can see that there's been a drastic difference, or a drastic change, drastic increase in the percentage of people who are obese. In the 1960s, just over 10% of the population was obese. But now, 2009, 2010, and even, it's about the same now. Anywhere between 35 and 40% of the population is obese. Okay, so when you look at the populations who are either overweight or obese, we're looking at about 70% of the U.S. population's at least overweight. Now, when we look at the population who's overweight and we look at the population who's obese, the people who are obese are at high risk for developing adverse health conditions. And adverse health conditions could be anywhere from a heart attack and stroke, to diabetes, to cancers, to amputations, to hypertension, to organ failure, so many different health conditions, and this is a preventable disease. Just simple modification to diet and physical activity, along with some other avenues that we haven't really talked about yet in this course, can help decrease the prevalence of obesity. In lots of cases, people, lots of cases, people just don't know. They're not aware. So it's our responsibility as educators, or at least my responsibility as an educator, to inform you guys and help you and anyone else that I can to become empowered in controlling their health. Okay. Now, the overweight population, there is some relationship between being overweight and adverse health conditions. But the overweight population also captures a unique population that's extremely fit, but also heavy. So you talk about people who are athletic or who are trained, who have developed the muscle mass. Yeah, sure, they weigh more, but it doesn't necessarily correlate to poor health. Okay, so the overweight category or designation is kind of a gray area, and if we look if we identify overweight and obese by what's called the BMI or body mass index, and if you fall into the overweight category, and if you know that you exercise on a regular basis and you probably strength train and you have a larger muscle mass than other people your size, then you may be overweight, but it's not. There's no relationship, or there's no increased risk for any adverse health condition. But at the same time, if you fall into that category and for sure you don't exercise and you don't eat right, and you're in that category, that you're on the other end. You're putting yourself at an increased risk, and really you're just going more and more towards the obese population. But those of you who are obese, and people who are obese nationwide, doesn't mean they're going to, suffer adverse health conditions. It means that they put themselves at higher risk or increased risk for developing several adverse conditions. Okay, so that's why these numbers are important. If you remember from my first video discussion on Chapter 1, we talked about the difference between mortality and morbidity. People who are obese, sure, they tend to die prematurely, but at the same time, they suffer a high level of morbidity because they're constantly having to go to the doctor for something, whether it's just a minor pain or a severe surgery or whatever. Okay. So that was the population for men. This is the percentages for women, and you can see that the overweight population in women, has stayed relatively the same. I mean, you could see an increase from start to finish, but that increase isn't a significant increase. But when you look at the percentage of obese individuals, you can see that there's a clear-cut, drastic change in the obese population. And one thing I haven't mentioned in either one of these slides is the green slope at the very bottom. This is the extremely obese population, and that's BMI over 40, which I'll talk about in a second. In 1960, among women, it was almost non-existent, and now it's almost 10% of the female population in our country. In men, same thing. It was almost non-existent. Throughout the 1960s and 1970s until about the, late 80s and early 90s when we started to see an increase in the percentage. But nonetheless, I mean, the extreme population luckily is still relatively low. But obese, if you're at an obese status, whether you're obese or extremely obese, you're putting yourself at risk for some adverse health conditions. Okay. So then, here's another slide that just talks about the numbers, and it's the same numbers. Looking at 1960, the overweight population was just over 30%. In 2006, it was still just over 30%. So it's kind of, what's happening with with these last two slides, and pretty much these two slides represent what's the data that's in this table. The obese population in 1960 went from 13.4% to 35.1% in 2006. And again, that's just, you can see that that's a drastic change. I mean, that's over 2 times the number that what was first reported in 1960. And then again, the extremely obese population went from less than 1% of the population to over 6% of the population. So there's been an increase there, not as drastic as the obese population, but nonetheless, it's still present. As I mentioned, these numbers represent, or the percentages represent, obese and overweight categories that are based on BMI, which you can see here is body mass index. And how you find your body mass index is, there's 2 ways you can do it. You can take your body mass and divide it by your height in meters square. Okay, so you take your body mass in kilograms, and then you take your height in meters, you square that, and then you divide the kilograms by square meters. Okay, that's one way. Or you can use your weight in pounds. So let's say I weigh 200 pounds. I multiply my 200 times 703. I get a number, and then I divide by the square of my height in inches. So it's pretty much the same unit. The unit is kilograms per meter square, but we hardly ever use that. But here are the categories. You have an underweight category, a normal weight category, an overweight category, and then an obese and extremely obese categories. Now, the underweight category, you might think, oh, well, that's good. Even with the underweight category, there are some health conditions some adverse health conditions, like the malnourishment, some nutrient deprivation, that's associated with underweight. So it's not really desirable to be underweight. It is desirable to be normal weight. If your BMI falls within this category, 18.5 to 25, kilograms per square meter, that category is least associated with adverse health conditions. Not to say that you would always prevent any adverse health conditions. No, there's some people who are normal weight who do suffer from adverse health conditions. It's just that number, or that percentage, is extremely low compared to the obese population. Okay, and that's where they get these designations. I mean, this isn't arbitrary. This is, over years and years. I mean, you can see starting in 1960, so over the course of 40 to 50 to 60 years, they've been assessing, the BMI of people who are sick, or, suffering from health conditions, from chronic diseases. And they're realizing that those who are suffering from adverse health conditions typically have a high BMI. And it's usually at this point. So they set a designation at 30. So that, and really it's an indication for you to realize, where you stand. Are you at high risk for developing adverse health conditions? Or are you doing okay? Is there opportunities to make some changes? So that's why we start looking at these measurements. Okay. So again, the overweight category, that's the gray area where, if you're in that category and you're athletically fit, then, you're not really at risk for developing adverse health conditions. But if you're in this category and you don't do anything at all, then you're pretty much, at risk that you ought to start changing some behaviors. Okay, so this is information that I just pretty much talked about. Here's another graphical representation from your textbook talking about the rise in obesity over the last couple of decades. You can see in 1990, the obesity rates were so low that no state presented more than 14% of its state population that was obese. But you can see from 1990 to 2000 that changed, and then most recently in 2011, there's several states that have a obese population of over 30%. So It's definitely has been on the rise, and I mean, I guess I'm assuming it's still continuing to rise. Okay. Now, in terms of biological definitions of obesity, it's characterized by the excessive accumulation of body fat. Okay. For those of you who don't know, body fat is okay, body fat is located just underneath the skin. We call this a subcutaneous fat layer or lipid layer. That's where adipose tissue is located. Okay, everyone has this, and the purpose of that adipose tissue layer is to insulate the body. Okay, now the more fat you are, the thicker that layer is, and you can see that this is the abdominal wall here, and this is the front view of the thigh, and then this is like, you know, the hips and the like the love handle region, if you will. All right, and you can see there's a thickness there. Like I said, everyone has this, but the bigger you are, I guess, the thicker this layer is. So how does this layer develop? And you can see here, fat cells tend to store calories. Okay. So, you know, where does this excess energy come from? What is this energy? So remember, calories is a unit of energy, right? It's the measurable form of energy. Okay. So when we consume food, when we eat food, and this is from, you know, this coming from your nutrition discussion just a chapter ago, our body breaks down all the food that we eat into basic components. And three components that provide us with the form of energy: the carbohydrates, fats, and proteins. Okay, they all enter, or I'm sorry, they all end up in the same place along the metabolic pathways. Now, for carbohydrates, you know, and you don't need to know all these details. But for carbohydrates are broken down to glucose, to glycolysis, and through pyruvate and all these different things until it ends up at the electron transport system. This electron transport system is what produces energy, okay, in the form of ATP. A breakdown of fat, it goes down a different process, but the endpoint is the same, okay? And then the same thing with protein. Goes down a different process, but then the endpoint is the same. So all three types of nutrients end up at the same place, which is the electron transport system. This happens inside the cell in the mitochondria. So hopefully you guys remember from like even junior high biology that the mitochondria is the powerhouse of the cell. And the reason why, and this is this right here. So this is mitochondria, this is mitochondria, and this is mitochondria. Well, that's what this is, okay? So the carbohydrates, fats, and proteins, along with oxygen, enter the mitochondria, and out comes carbon dioxide. This is the carbon dioxide we breathe out. And then also ATP. ATP are units of energy. ATP stands for adenosine triphosphate. Those of you who are kinese majors will eventually, you know this, you know, front and back. But for you, those of you who've never taken a kinesiology class and, you know, aren't familiar with the concept of ATP, for you it's just simply a unit of energy. All right, where does that energy go? Anytime we move, our muscles contract. Our muscles need energy. They need ATP. All right, so the food that we eat gives our muscles an opportunity to work. Our nervous system needs ATP. So the food that we eat gives our nervous system an opportunity to function. Okay, and then there's other metabolic processes that must occur: enzymes, hormones, transport, you know, cellular functions. All of this needs energy. So again, the food that we eat provides our cells with energy in order to function. Okay, so in other words, we need to eat to survive. Okay, but what happens whenever we eat too much? And that's where we start to get in trouble, okay? We either eat too much or we don't exercise enough, okay? Now, the typical American needs about 2,000 calories just to maintain body weight, okay? Now, that doesn't account for everyone. It's just the average, okay? So what do those 2,000 calories, you know, mean? Well, 12 1,200 of those calories are needed for just body processes, and then 800 just for normal daily activities. And that doesn't really account for exercise. So if you exercise, and if you're burning off another 300 to 500 calories per workout, then that would be an additional 300 to 500 calories you would need to maintain body weight. Okay. Now, if you burnt off 2,500 calories in just one day, you're not really going to see. You're not going to notice a difference. You're not going to see a change. But if you did this on a regular basis, where you're burning off more calories than you're consuming, then you will definitely start to lose weight in the form of body fat. Okay. So you want to decrease the amount of body fat you have in your body. Okay, so that's where we're consuming less than we use. If you want to maintain, then you consume the same amount as what you use. And if you're trying to gain weight, then you would consume a lot more than you use. So you would eat a lot more than you exercise. And that's what most people do. Okay, and I'm not saying most people like arbitrarily. No, we just saw the numbers. 70% of our population's at least overweight. Okay, so here's another graphical representation of energy balance. You can see here from this list, it shows how much calories it shows a list of activities of calorie utilization, from the highest at the top to some of the lowest at the bottom. Okay. Another term that's associated with obesity is childhood obesity. They're physiologically they're the same disease, but conceptually they're different, because with childhood obesity, so just going with childhood development, children grow by increasing the number of cells in their body. That's mitosis. You know that from high school biology. So we grow by producing a lot more cells than that are destroyed. Okay. At some point in our lives, when we reach maturation, usually in our 20s, anywhere between 20 and 30 years of age, we kind of level off, where we're no longer producing more than it's being destroyed, that we're actually losing. And then as we age, all the way until death, we start destroying more cells than we produce, and that's why we get smaller and smaller and more and more frail. Okay, so with the concept of childhood development, again, you're talking about an astronomical increase in the number of cells in the body, which allows the body to continue to grow in size all the way up until maturation. Well, with childhood obesity, it means that there's an increase in the number of fat cells in a child's body. So whenever that child grows, those cells, so that large number of cells, each of those little cells grow in size. So now you have a large number of cells that are very, very big. So a child who's diagnosed with childhood obesity has an increased risk of developing adult obesity. Okay, now what's the difference? Well, again, whenever a child is growing in size, each of those fat cells increases in number. And then whenever they get older, whatever number of fat cells are available, each of those fat cells gets bigger and bigger. Whereas a child who's not diagnosed with childhood obesity, they don't have those large number of cells. Sure, they have a certain number of fat cells, but whenever they get older, only that limited number of fat cells increase in size. So there's a big difference in the number of cells that are actually increasing in size. All fat cells are going to increase in size. It's just that people who are suffering from childhood obesity have a higher number of those cells. So whenever each of those cells increases in size, it causes the overall person as an adult to get bigger and bigger. Okay, so that's the difference between childhood obesity and obesity. let's see. So this slide, you can look at these slides to see what the effects of obesity is on the body. You can see on the left side of this slide, you can see a list of negative health effects, including increased risk for several adverse health conditions. I've mentioned those before: stroke, cancers, dysfunction of the body. So there's and then obviously the heart attack and clogged arteries, increased LDL levels, lowered or increased LDL and triglyceride levels, and decreased HDL levels, increased blood pressure. I mean, as you might imagine, if there's blockages throughout the arterial system, the blood is just going to be backed up all the way through, and it's just going to increase the blood pressure throughout the body, even at rest. Okay, so several adverse health conditions, and I mentioned earlier it's the left side that says a negative. No, it's both sides. So both the negative, but both the left and the right sides present negative health effects. Okay, you can see that. Okay, so this graph is showing the difference between a fit body and an unfit body at 3 different stages. At looking at first at a lean body that's fit and unfit. Even a lean, unfit individual has an increased risk for developing adverse health conditions. And then you look at the bottom, it shows the numbers for a fit obese person and unfit obese person. So even obese people can become fit, and whenever they do, they decrease their risk for pretty much for several adverse health conditions. So that's what that slide is showing off. Okay, and so you can watch this video. This is actually an interesting video. I encourage you to watch this one. Just type in, just Google "keeping it off" ABC News, and you can watch the video. It's about a guy who kind of like one of those the Biggest Loser contestants, and how he's talking about how he's managed to keep weight off since he left the show. So pretty interesting video. All right. So now I'm going to go into Chapter 8, Understanding Body Composition. And really this chapter is talking about how we assess body composition. Now, if you were in a face-to-face class, I would send you to the lab and I would let you play with all our tools. But unfortunately we don't, but I'll try to cover as much as I can. So body composition, by definition, it measures the relative amounts of lean tissue and fat tissue in the body. So when we talk about lean tissue, we're talking about fat-free tissues such as muscle, bone, skin, and other organs and body fluids. Fat mass is made up entirely of fat tissue. Okay. So the percent body fat is the percentage of the total body weight that is fat tissue. All right. So the higher your body fat percent, or your percent body fat, the higher the risk for developing adverse health conditions. Okay. So this is what should be ideal in terms of body composition for men and women. You can look at all the other categories, but you look at the fat. So what's ideal for men is about 15%, and for women it's about 25 to 27%. Okay. Let's see if I'm going to come back to this. I thought I had, yeah, right here. Here's another chart that indicates, or that shows levels of body fat norms for men and women. You can see that the obese categories are, for women, over 32% body fat, and for men is over 26% body fat. For acceptable, women is about 25 to 31, which that chart that I just showed you, showed. And then for men, it's about 18 to 25%. Okay. For fitness individuals, or individuals who are fit, their body fat percentages is in their low 20s in females, and mid-teens for men. All right, you can see what it is for those who are athletes. Okay. I wish I would have had those two slides back to back, but oh well. You could look at your body shape to determine whether or not you're at risk for developing adverse health conditions. You can see here, this is a general concept. You have the android versus the gynoid body shape. The android body shape is like an apple shape, where most of their adipose tissue is in their abdominal region. So it's like a big, round, people who have a lot of body fat in their upper body, kind of like the first picture right here. This would be an example up at the top of gynoid obesity. Now, the picture on the bottom is a good example of I'm sorry. This is the picture at the top is android obesity, and the picture on the bottom is an example of gynoid obesity, and that's the other body shape. So individuals that have a gynoid fat patterning are not as likely to develop adverse health conditions. Most of their fat is in the hips and thighs. Okay, so android is at greater risk. So that might be an indicator for you. You can look at your own body shape and say, "Oh man, I'm android. I'm at risk, so I need to start doing something about it." Here's a chart showing all the BMI categories. The green is normal weight, and you can take an individual that's 6 foot and weighs 140 pounds, and they're in the green. Whereas you take that same height at 6 feet and 240 pounds, they're in the red. That's an obese category. All right, so you can see where you stand there. So I've already talked about how you can assess BMI. You simply take your weight. You can take your weight in pounds, multiply by 703, and divide by a square of your height in inches. Okay, and you can look at the beginning of this lecture to find that formula. Body circumferences. Circumferences. Yeah, I said it right the first time. We can look at the waist and hip circumference to determine a ratio. So the ratio should be less than 1, meaning that your waist circumference should be greater than your hip circumference. But whenever the ratio is greater than 1, then you're at risk for developing adverse health conditions. All right, so these are all just measures of really risk for adverse health conditions. There's some other devices that we can use. Now, at OLU, we don't have the funding to be able to purchase these products, like the DEXA at the very top, the dual energy X-ray absorptiometry, whatever we call it, DEXA. I don't ever use the long term. DEXA is an $80,000 piece of equipment. It's when I think I have a picture. Yeah, that's a representative. I mean, an example of a DEXA machine. It's like an MRI scanner. The arm at the top just kind of scans the body. It just moves from top to bottom, and then at the end, they can calculate. I mean, not only fat percentage and body fat percentage and lean body mass, but they can talk about bone density, and that's what it's used for, is for bone density, but it still measures body fat. Hydrostatic weighing or underwater weighing. This is an example of underwater weighing. So there's like a small pool that whenever so a person has to sit on a chair that's pretty much a scale. So whenever the person sits on the scale, he or she is out of the water, and they can measure how much that person weighs on that scale, and then they submerge that person, and then they look at the difference, in their weight after they've been submerged, and they have to like blow out all their air in their lungs for about a minute. So it's kind of uncomfortable, but it's not painful. It's just uncomfortable. You can't breathe. I mean, you're not restricted. I mean, you can. Well, maybe you are restricted. I can see there's a weight belt, but we don't have that capacity, so we don't really worry about it. This is another device known as the BOD pod. It's called the air displacement pod. It does almost the same thing as the hydrostatic weighing, except for there's no water. You just you sit in there, you close the pod, and then there's a way to I don't know if they decrease the pressure or increase the pressure or do something, but they can assess body fat percentage. We don't have that capacity, so again, we don't really worry about it. This is something we have, the BIA, the bioelectrical impedance analysis. This is pretty cool. It's so you turn it on and then you set it up. You have to set like your height, your weight, your age, and your sex, and then you press start and you grab both handles. So one of those handles actually sends an electrical current into your body. So it travels all the way through your body, and then it's received by the right side, lead or whatever, the hand placement. Okay. So I guess it determines, how fast the electrical goes or how strong the electrical goes throughout your body and how it's returned. And it can assess, what your body fat percentage is. Pretty cool. We have a couple of those in our lab. Skin fold measurements, or we use the calipers, which is what we see here. This is a rather basic caliper. We have some pretty expensive ones in our lab. But you take measurements at 3 different sites. For men, it's like your upper, your chest, your bicep, and I believe your thigh. And then for women, it's I think it's the suprailiac. I forget where it was. I mean, to be honest with you, if we were in a lab, I would have the lab sheet to help me out. But I think you take 3 measurements, you add them all up, and then depending on where you are, it will help to determine whether you're at risk for developing adverse health conditions. So what we do in a lab is I have students. There's like 5 or 6 different ways to assess body mass or body composition in our lab, and what I do is I have all the students do all of the tests. And then, each test has a category for those who are at risk for developing adverse conditions and those who are not. And what I try to get them to do is try to understand or try to see if those categories are consistent. So, for example, they can take their BMI and then waist circumference, and both of those will have categories that indicate risk or high risk. And I want to know if they're at, are they in the same category in both assessments? And that's what we do in the lab. And that's it. This one was a short one. So I told you, there's a reason why I have, chapter 8 and chapter 6 combined. So now we've covered all the chapters except for chapter 5. I don't even remember what chapter 5 is about. I've never covered it. So you're not missing out. All right. Well, that concludes this one. I'll post this as it becomes available to me, and I'll start working on chapter 9, which is stress management. Talk to you guys soon.